Today we're going to be talking about cylinders and cones. And I have here a figure, and this is called a net. And what a net is basically if I were to take apart a three-dimensional solid and write it as the different figures or show the different figures that it makes up, this is the figure that a cylinder is going to make up. And what type of solid does a cylinder resemble? It resembles a prism. So we're going to be using that idea to get our lateral area, our total area, or the surface area, and the volume. So the lateral area from a prism is the perimeter of the base, while the perimeter of the base is the circumference of that circle. So that's 2 pi r times the height. So the lateral area is 2 pi r times the height. Now what you have when you break down that area, that's going to be a rectangle. 2 pi r and the height. Now the total area, 2 pi r h plus 2 pi r squared, as you have the area of the top and bottom. Now the volume is the area of the base, which is a circle, 2 pi r squared times the height. No, not 2 pi r. Because volume, it's just the volume of one of the base, so it's pi r squared. Okay. First example, we need to find the lateral area, the total area, or the surface area, and the volume. And let's leave everything in terms of pi. So lateral area is 2 pi r h. So perimeter of the base, circumference of the base, times the height. So 2 pi 5 times 12, that's going to be 120 pi square centimeters. Now the total area, 120 pi plus 2 pi times 5 squared, the area of each one of the bases. Well, this is 25. This is 2. 5 squared is 25 times 2 is 50 pi. So that's 170 pi square centimeters. So then volume is area of the base, pi r squared times the height, which is 12. So that's going to be 300 pi cubic centimeters. Now a cone. And a cone resembles a pyramid because it has an apex or a vertex. So our lateral area for a cone is 1/2 perimeter of the base. Well, the base is a circle, so that's 2 pi r times the slant height. Remember, this is the slant height. We have radius of the base. That's our height. 2 pi r times the slant height L. Well, if you multiply 2 times 1/2, you get pi times the radius times the slant height. So for our total area, you have the surface area, or the lateral area, plus the area of the base. Now volume. Remember, volume for a pyramid was 1/3 area of the base times the height. So our example. They give us the whole diameter of the base is 12, so that is 6. We use our Pythagorean theorem to get the slat height, which is 10. So our lateral area is pi times the radius times 10. The slant height, so that's 60 pi square centimeters. So for total area, we take the surface area plus the area of the base, which is 36 pi, to get 96 pi square centimeters. Volume 1/3 area of the base times the height, which is 8. So that is also 96 pi. But now we're talking about cubic centimeters. Right, so those were two basic examples. Some more challenging examples. A regular square pyramid is inscribed in a cone with radius of 4 and height of 4. What is the volume of the pyramid? Okay, so I'm going to try and draw this as best I can. You have a cone, and inside of that cone, we have a square pyramid. Okay, so we need to figure out what is the volume of the pyramid. Okay, so volume of a pyramid is 1/3 area of the base times the height. Well, let's look and see what they give us. They give us the radius and the height. So the height is 4. Our height is 4. They also give us the radius, which that is 4. So I need to figure out what one of the side lengths is. If I drop down the perpendicular from the center, perpendicular to the side, that's half the length. It is equal to half the length of the side of our square. Well, that's a 45, 45, 90 triangle. So half the square is 4 over root 2. So I simplify my denominator. So this is half the side. So the entire side is going to be 4 root 2. So plugging into our formula, volume is 1/3 area of the base. Well, the base is 4 root 2 squared times the height, which is 4. 4 root 2 squared. That's going to be 16 times 2 times 4. So this is 128 over 3 cubic centimeters. Now find the slant heights of both the cone and the pyramid. So let's talk about the cone. So just talking about our cone. You know, the height is 4, the radius is 4. So the slant height there is going to be the square root of 4 squared plus 4 squared, or 4 root 2. So that was our easy one. Now the pyramid, though. So our pyramid okay, we have found that the height is 4. From the center perpendicular, that was 4 root 2. I'm sorry, it was 2 root 2. It was half the length of the whole side. So in order to find the slant height, which is from our vertex perpendicular, that line there, we again have to use our Pythagorean theorem. So it's the square root of 4 squared plus 2 root 2 squared. That's going to be 16 plus 8. So that's going to be the square root of 24. Square root of 24, I can pull out a 2 root 6. Next example. The lateral area of a cone is 3/5 of the total area. Find the ratio of the radius to the slant height. So the lateral area is, remember, is means equals 3/5 the total area. Well, lateral area, that's pi RL, or pi times the radius times the slant height. The total area, well, that's pi RL plus the radius, or the area of the base. So simplifying that, I have pi times r times l. Distributing the 3/5 through. 3/5 pi RL plus 3/5 pi r squared. Now, really, pi RL and 3/5 pi RL are like terms. So I'm going to subtract this over to the other side. So I have 1 minus 3/5, or 5/5 minus 3/5 to get me 2/5. Now let's look at what we have here. I have a pi on both sides. That can cancel out. I have, if I divide both sides by an r, we get that. So really I have 2/5 times the slant height, 3/5 times the radius. If I multiply both sides by a 5 to get rid of that denominator, I get 2 times the slant height, 3 times the radius. Now I'm looking for the ratio, so a fraction, of the radius r to the slant height. So I'm looking for r over l. So I need to divide by the 3 to get rid of the 3 on the right. And I need to divide by the L so that I can have the ratio of R over L, and that is 2 to 3. Okay, there are your lesson questions for the day. Please make sure they're submitted on time.